All right, so we're going to go on and start on chapter 10. Now, the first thing we're talking about in dealing with is line. So we want to find the inclination of a line. It's dealing with slope, and it's actually an angle. So we're talking about an angle here instead of the slope rise over run. We also want to find the angle between two lines and the distance between a point and a line. Now, an indicated line in the yield section will look at the term of slope in terms of an angle. So the indication or inclination of a non-horizontal line is the positive angle less than pi, measured counterclockwise from the x-axis to the line. So we're talking about an angle less than pi, so that means it's less than 180 degrees. So a horizontal line is going to have an angle of 0. It does not have any slope. It does not have any inclination. Now, if it's a vertical line, it's going straight up. It's going to be 90 degrees or pi over 2. Now, anything less than vertical in the positive direction will be theta, or essentially less than 90 degrees, less than pi over 2. And anything as a negative slope is going to have an obtuse angle. So negative slope would have an obtuse angle. Positive slope is going to have an angle between 0 and pi over 2. Now, if a non-vertical line has an inclination theta and slope m, then we can define it by the equation m is equal to tangent of theta. So the slope is equal to tangent of theta, or theta is equal to tangent inverse of m. Now, we do need to be careful with this here. Now, tangent inverse is restricted on the interval of 0 to, or negative pi over 2 is less than or equal to theta is less than or equal to pi over 2, which is fine, but because the angle of inclination that we're looking at is not pi, is going to be theta is less than or equal to pi, anything that ends up between negative pi over 2 and 0, we're going to have to turn into a positive angle. Because an angle that is between pi over 2 and pi, in tangent inverse, will show up as a negative angle. Because it's restricted from here to here, but the angles that we have, we're going to go from here to here. So the angles that are supposed to show up here are going to give a value down here. So we need to adjust it and bring it back up. Does that kind of make sense? So if we do end up getting a negative angle, we have to add pi to it to get it back to the proper angle. So when we look at these here, find the inclination of, we'll start off with x minus y equals 2. We need to find the slope. So the easiest way is just to solve the equation for y. Equals x minus 2. Thus, our slope is because it's going along the form y equals mx plus b, where m is our slope. So since m is our slope, our angle of inclination, theta, is equal to tangent inverse of 1. And tangent inverse of 1 is 45 degrees, or if we have it in radians, can convert that into pi over 4. So our angle of inclination for the first one here, x minus y equals 2, is pi over 4. And that's it. Questions on this one here. All right. And it does make sense because here we do have a positive slope, so we should expect an angle between 0 and 90. Let's look at the next one. 2x plus 3y equals 6. So we would subtract 2x from both sides, which would tell us that 3y is equal to negative 2x plus, and then we would divide by 3, which will tell us is y is equal to negative 2/3 x plus. And our angle would equal tangent inverse of okay?
Negative 0.588.
Did you do it in degrees? Now, this is a negative angle, so we have to add pi to it. So our angle of inclination is 2.553. And unfortunately, it doesn't give us a nice angle for this one, but it is what it is. Any questions on either of these two here? So the first one we have is 45, or pi over 4, 2.553, or 146.3 degrees. And that's it. Any questions on any of this here? Now, if I want to find the angle between two lines, when two distinct lines intersect and are non-perpendicular, or their intersection forms two pairs of opposite angles. One pair is acute, and the other pair is obtuse. The smaller of these angles is the angle between the two lines. If two lines have inclinations of theta 1 and theta 2, where theta 1 is less than theta 2, and theta 2 minus theta 1 is less than pi over 2, then the angle between the two lines, theta, is equal to theta 2 minus theta 1. So what we're saying is that theta 2 is less than theta 1. So this angle is bigger than this one. And the difference between these two is less than 90 degrees. Now, as we said, for any inclination, for either of these two angles, neither one of them can be greater than pi, correct? So neither one of these can be greater than pi. And, well, so even if it is barely equal to pi, well, the only way that I can subtract two angles and get pi over 2 is if one of them is pi and the other is pi over 2, or if theta 2 is bigger than pi, because that's the only way I can get to pi over 2. Otherwise, the angles will be small. Now, let's actually look at a picture of this, like here. Theta 2, theta 1. So this angle here is going to be the same as theta 2 minus theta 1. It'll always work for any case. Now, it'd be nice if we do have a formula for this. And we do, and we can take that tangent of theta is equal to tangent of theta 2 minus theta 1. And using our different angle formula, our subtraction of two angles, we get this formula here. And we can kind of convert it over if we went through using slopes to see that tangent of theta, so difference of two angles, is going to equal the absolute value of slope of the second line minus the slope of the first over 1 plus slope of the second times the slope of the first. And then once we get whatever that value is, we can take tangent inverse of it to get our actual answer. So, let's find the angle between these two lines. Now, the key thing that I actually need is the slope for both lines, because if I can have the slope, then we're good to go. So, if I want to find the slope, the first thing we can do is subtract 2x from both sides, which will tell us negative y is equal to negative 2x plus 4, because we subtracted 2x. Multiply it all through by negative 1. And this here telling us the slope is 2. We would subtract 3x from both sides. So all we really care about is the negative 3. Now again, we said theta 2 is going to be the bigger of the two angles, whichever they are. Now looking at this here, which one's going to have the bigger angle? A negative 3/4, because when we look at a graph, negative 3/4 plus 3 would be something like this here. 2 would be something like this here, and they're not going to intersect it right there. They're actually going to intersect somewhere else off the graph. It's just coincidence, because it would be 2, yeah, no, they intersect the graph at 2, 0, and okay, that's better. Because here, y is going to be 0 when x is 2. Here, y is going to be 0 when x is 4. So they should be at different points. So this here is our theta 2. This here would be considered our theta 1, or m1 and m2. If we have a negative slope, it will always be the bigger one, because we're coming from this direction. So to find that angle, we'd have tangent theta is equal to, well, m2, which is over 1 plus negative 3/4 times 2. Well, the denominator, we can do this multiplication pretty simply. It'd be negative 3/2. On top, well, 2 is the same as 8/4. We don't have the 2 anymore. Negative 3 minus 8 would be negative 11/4. There's negative 11/4. 1 plus negative 3/2. Because I have 1 would be 2 2's. So negative 3 plus 2 is negative 1. Now this here would be the same as saying the absolute value of a negative 11/4 divided by negative 1/2, which would be the same as saying negative 11/4 times negative 2/1. 1, 2, which gives us so any questions on how we got to 11/2. So what's our angle? Yeah, because tangent theta is equal to 11/2. So, right, we have to take tangent inverse of 11/2. 3.390. 1 point. I was like, that looks a little big. 1.390 would be our angle between these two lines. Now, could we have typed all of this here into the calculator? We didn't even... Yeah, we could have typed this whole thing here into the calculator, and if it gave us a negative answer, we could have just changed it to being positive because of the absolute value bars. Now, if you're wondering why are we talking about absolute value bars with this here, okay, you're just going to be annoying. Okay, come on. Yeah. Because this angle here, we said both of these are going to be less than pi, yes? And their subtraction here is less than or equal to pi over 2. So pi over 2 is this here. Well, both of our values for tangent are positive and positive because tangent is rise over run, positive. And this direction is positive. So whenever we take tangent of theta in this region, whatever our rise over run is, whatever that amount's going to be, has to be positive, yes? That's why, fix that later, this here has the absolute value bars, is to make sure that this stays positive. Which means we could have flipped M1 and M2 and gotten the same answer for what we just did, because we had negative 3/4 fourths over 1 plus 2 times so the numerator would have been 8/4 minus which would have given us 11/4. Now in the denominator, you're going to get 1 minus 3/2. Because then we'd end up getting 11/4 times negative 2 over 1, which is negative 11/2, which is almost what we got, but remember, if we're taking the absolute value of it, it turns it from negative to positive. So it actually ended up working out that it really didn't matter which one was bigger or smaller because the absolute values took care of it. Does that make sense? We need to see another example of one of these. Okay. See here. Let's go to the textbook because actually, why not? Zach, give me An equation, number in front of x, number in front of y equals a number.
2x plus 7y equals 13.
Tori, same thing. Okay. Thought this would be a little bit more interesting than just pulling something straight from the book. So, we need the slope for both of these here, yes? So, what would we do first? We'd subtract the 2x, yes? And then what?
Divided by and that one would be 20 over 4, so 5.
Well, we would subtract the 4x and then divide by
2 is 10. I divided by the wrong number.
And this is a fast shortcut way to do it, because if we did, hold on. If we did the step shot, we would have subtracted 2x, which would have given us 7y equals negative 2x plus 13. I really don't care about 13. By 7. Now, the reason we can do this is because since we only care about the slope, I don't care what this number is, we're good, since we're just finding the angle. If we're wanting to actually graph it, then we would need the y-intercept. Now here, when we subtract 4x, we would get 2y equals negative 4x plus, divided by 2, we would get y equals negative 2x. Which, doing stuff like that there is helpful on any type of standardized test. But, looking at this here, to finish this off, we're going to take tangent of theta is equal to the absolute value of negative 2/7 minus 2 minus negative 2, which is the same as plus 2. 1 plus negative 2/7 times negative 2. Now, negative 2/7 plus 2, well, 2 is 14/7, so this here will be so 12/7 divided by, well, because that's going to be 7/7. 7 plus 4 is 11. Now to multiply, we would change it in flip. So theta is going to equal to tangent inverse of 12/11. Is going to be our overall angle for this here. I think I clicked on the wrong thing first. There it is. negative 2/7 x plus 13/7. And negative 2x plus 10. Okay. All right, I just thought it would be good to look at the graph of these here and see how these look. Negative 3. Alpha y equals 7x plus 13 alpha y equals 7. Figure that out. Negative 2x plus 10. Yeah. So we have a angle greater than there. So our real angle between these two would be this little one right here. Because they want it above. So it should be pretty small. Yeah, because we have a big angle minus a big angle, which would give this here. I might not technically like this, using these two equations, mainly for the fact that, okay, it should be fine. Because when it was going through the overall definition at the beginning, it wanted theta 2 to be greater than theta 1, and the difference between these two to be less than 90, which I think this works for this here. So we're good. Thinking before I talk, so. But that's it with that part. Questions on any of this here? Distance between a point and a line. Finding the distance between a line and a point not on the line is the application of perpendicular lines. And it works out that the distance between a point x1, y1 and the line ax plus by plus c equals 0 is equal to d ax1 plus by1 plus c over the square root of a squared plus b squared. Plus b y1 plus c all over the square root of a squared plus b squared. Well, the bottom part of this fraction here, square root of a squared plus b squared, is Pythagorean theorem. Or kind of along those lines. So what we're going to do is we're going to find the distance between 4, 1 and the line y equals 2x plus 1. Well, the first thing we need to do is manipulate this here and get this equal to 0. So we need to move everything over. So I'm going to subtract the 2x. And we're also going to subtract the. So that means for us here, A is, B is, C is, X of 1 is, and Y sub 1 is 1. So for overall distance formula, we can plug this in, and we'd have the absolute value of A times x1 plus B times y1 plus C all over the square root of a squared plus b squared. Well, negative 2 times 4 is negative 8. 1 times 1 is 1, minus 1. Negative 2 squared is 4, and 1 squared is 1. Now, the numerator would just give us the absolute value of negative 8. And the denominator will have the square root of. Now, if we want to rationalize the denominator, we would multiply the top and bottom by the square root of 5. square root of 5 over. So the distance between the point and the line is 8 square root of 5 over 5. That's it. Yeah, so really, once we get this equation, the equation of the line equal to 0, then we can use this formula here. But these formulas here only work on linear lines, because we'd have to have a different formula if we're talking about any type of higher degree polynomial function. .58 or 8 over the square root of 5. It didn't copy over well. And that is it.